Well, welcome to the final event, y'all. You guys had your finals, now we have ours. So just kind of like a brief overview of what we're doing. We just kind of wanted to make a presentation and share our journeys throughout this, lessons learned, and kind of turn this into more of a conversation and reflection of what this class was, what it might be, and yeah, lessons learned along the way. Thank you guys so much. This was really I truly mean this. I think this is the most gratifying and fun thing I've ever done in my 4.5 years at Olin. It's been really special. I'm really gonna get emotional, not realize I'm gonna see these three people the next 3 times a week for the next years. So thank you guys so much for coming. If there's any questions at any point along the way, please feel free to interrupt. Do not even just yell. So for what we want to go over, we kind of want to discuss our philosophy and why we wanted to teach this course, what we covered along the way and how we covered it, because we believe the methods were also equally as important as the content, what students told us along the way and how this might be in long-term learnings and what might be go through at the end of this. Because ultimately we had about 8 students in the class go through all the way, and we've really enjoyed it, but we want to see how much we can make that long lasting and just have an open conversation about that. Some of our key motivations and why we wanted to teach this course is we felt that there was some things in classes that the standard Olin curriculum as we had experienced were discussed, but maybe perhaps glayed over and not gone into as technically sound or deep that we had really wished, and had to find either somewhere else through project teams, internships, or final capstone experiences, that it was felt a little difficult to know what you don't know and how you can discover more of that. And what leads into that as well is finding solid references and resources that help you pursue what you don't know on your own terms, meaning if my first line of defense, if I want to learn more about bolted joints and I go Google bolted joints, I'm going to have so many resources and content that I really don't know how to parse through. How can we do that and encourage students to build their own resources and references that will help them succeed in the future? We also wanted to allow explore how we could present and teach about more advanced mechanical engineering concepts through outside just the standard more chalk and talk. How do you present something that is a step-by-step diagram or very visually intense in a very concise manner, and making that available for students in the future, because notes are fantastic and I copy down what a professor writes, that is helpful to me, but also pristine visuals are amazing. And lastly, we really wanted to explore some ethical implications of what we can cover, what our jobs are as mechanical engineers, and how that relates to what we make and who can use it, but also the safety implications of if a consumer or something is going to be using, how can we ensure and make sure that that is as valid of an analytical lens of, is this going to break, and if it does, who might be hurt? So yeah, but more for the actual content and why we're what kind of motivated us to do this is that we felt our experiences that in mech solids you get introduced to a lot of fundamental mechanical engineering concepts, and you get introduced, and ideally, or in our minds how it's presented, you expand upon that in mech des and you build and create wonderful projects that you can then go forward are fantastic resume builders, and also gives you real hands-on experience. However, where we felt is that there was just a little bit of an intermediate step that felt slightly missing. There's concepts that you get introduced to in the fundamentals, you learn the language of the land, but when you jump to mech des, a lot of students feel perhaps there's a little bit of extra sauce that is just missing. And sometimes that can be filled with project teams, internships and co-ops, or doing research with professors. But we really wanted to find a way of what if we could find a way that is prescribed in the mechanical engineering program that doesn't cover everything, because that's impossible, but definitely broadens your worldview a little bit more. And so ultimately, to put in just concrete words, what is the goal of this is we wanted to bridge that gap. We wanted to find where did I leave mech solids and where did I start mech des, and how can I what feels missing in there. Fundamentally, we want to give the chance for students to review the content and feel fundamentally strong that in core engineering skills you get in mech solids, and build past that so that you can very concretely and confidently design and analyze your designs in mech des and in the future. So to give like a full acknowledgement and thank you, a lot of the content that we do cover was a transfer class that I took when Olin first went remote through UT Austin. Dr. Black taught a course called Machine Elements that was very pivotal in my engineering education, and I thought was wonderful and is the basis for a lot of what we taught. What did we teach? We really wanted to break it up into 3 different categories. We wanted to spend the first couple of weeks really like nailing down key concepts in mech solids that feel like critical, expand upon that, and then push some little extra like topics that we think are interesting. So for mech solids, really nailing down free body diagram, stress transformations, beam bending, getting a fundamental understanding like the back of your hand. And then from the machine elements course, what can we bring in that like actually goes through? So failure theories, fatigue, wear, shaft loading, bearings, gears, bolts, belts, like machine design elements that are you're more than likely than not at one point going to at least look at in your engineering career. And lastly, do a little like foyer into a brief dip into FEA and the tools. We'll talk about that ethics before, and lastly, give the chance for alumni or other guest speakers to kind of share their perspective as mechanical engineers. So we had these buckets. We knew we wanted to cover them. Like rubber meets road. Like we made a schedule to go actually tackle all that through. Like how are we going to revise homeworks and go around that? You don't need to read this at all. And like we're really happy that actually the schedule, shockingly, like we stuck to it pretty tightly. Which I don't know, Rob and Chris, you probably can share some insight into that of how flexible you need to be in your curriculum. But we were really happy that how well the original mission we stuck to.
Cool. So now we're going to talk about a little bit about how we covered it, kind of our thoughts and methods behind how we present the information, like Carlos alluded to earlier. So the kind of the first thing is basically these are some example slides from Dr. Black's presentations. He was kind enough to share a lot of his resources in his presentations and homeworks with us. So we drew pretty heavily from that for like kind of the flow of things and like the subject matter and how it broke down in classes. However, a lot of the stuff from that class was kind of these more dense slides that were a little bit difficult to read, and a lot of like diagrams taken right out of textbooks and things. And so we wanted to take that a step further. And since we're trying to cram so many subjects into a 2-credit class, we had 4 credits worth of like lecture time, but we had very little homework time. So we're trying to get as much information across as intuitively as possible. And so one of the ways we did that is by making our own diagrams for a lot of things. So we have a couple examples here. So for example, right here, this is kind of the way we presented Moore's circle, which for those who don't know or may not know is kind of a way, like it's one of those like classic mechanical engineer ways of representing like stresses within a part. That is kind of a graphical way to see the math behind something, that makes it a little bit more intuitive. So it's sometimes not taught in MechSolid, sometimes it is. I think it usually is in some form, but we wanted to highlight it just as kind of a transition thing moving through our class. So this is kind of the way, this is like an example of something we stepped through. So we kind of had this common practice problem that we kind of flowed through and we kind of kept coming back to as we kept adding kind of more complexity to the subject. And so this is kind of how, this is just kind of a quick example of how we did this. So like a lot of like textbooks, if we look back here, we'll have like some kind of diagram and in 3D, but we wanted to kind of make it really clear. So basically each face is highlighted, and as we keep adding principal stresses, we kind of build up the diagram step by step, which you can't just get out of like a normal textbook drawing. So that's kind of one quick example of that. Another one is looking at like kind of cyclic fatigue loading and Goodman failure. So talking about like an average stress and amplitude stress, and then plotting that out kind of step by step to make it a little bit more easy to understand quickly because of our limited time frame. So it seemed to be pretty effective. We can discuss that later when we get to our discussion and see what the student said. Another thing we used quite often is videos and animations. So there's a couple of YouTube channels in particular. Efficient Engineer has really amazing 3D animations and videos. Jeff Hansen does a lot of like more like whiteboard talk throughs of problems. But we like a lot of times in our slide decks, we would sometimes we'd show these videos in class as a way of like introducing a topic. Because again, we didn't have, it's a 2-credit class, we didn't have a lot of time outside to have students do that. So we just, we had enough class time that we were able to like show parts of these videos. So like, for example, this is like an I-beam shear loading, but it's a really cool way of like visually representing that. And also we also showed like a video of fatigue testing to kind of give people an idea of where that, because all this data and all these equations come from somewhere, but they all come from testing kind of like this. So we wanted to give everybody a kind of like a physical sense of where that data comes from. So yeah, we use these a lot. And we also included more videos at the end of our slide decks that we used to help like build our own knowledge, but didn't necessarily watch in class for people to reference later. And then here is one of Colin's spectacular bolts analysis slides. So one of the parts, the huge parts of the kind of our philosophy here was that we didn't want these slide decks to be designed just for the presentation and the lecture in class. We also wanted them to be really powerful as a reference material later. So if you notice on the side here, we have these kind of tabs. So there's 5 different types of tabs. We wanted people to be able to scroll through a PDF that's like 60 pages long really easily, be able to jump right to the pages they need. So the green, for example, is reference. So this is kind of a reference slide that you could go back to later if you ever needed to double check something. And yeah. And then, yeah, so kind of one of the big things coming out of this is we're kind of interested in exploring this kind of mix of slides and chalk and talk. So like we very, very heavily relied on slides for our entire class. And like, you know, we basically wanted to do that because of the amount of pace we wanted to hold. So we wanted to carry a really fast pace, meaning we could cover material quickly. So the slides are much better for being able to move quickly and show intuitive visuals, stuff like that. It's also very easy to refer to later. However, that comes at a big sacrifice of actually having students be able to do, we had some practice problems, but a lot of you guys suggested having more practice problems. And I think we also wanted to include more practice problems. We kind of ran out of time to do that. So basically the chalk and talk method is way better. Like after we kind of see that it's way better for kind of workflow and like teaching a student like learning the path through a way to do a problem. So that was kind of probably the weakness of this class in particular. It wasn't really designed for that. And also we don't really have enough experience to come up to a whiteboard and draw out the whole problem. We probably could have gotten through it, but it wouldn't have gone as smoothly probably. So the slides really worked well for us. So basically we're kind of wondering if there's this kind of cool happy medium that could arrive in the future of having these slides and having the reference material and the visuals, but also having kind of the chalk and talk format in class as well, kind of having a mix of both to kind of get the best of both worlds. So that's something we'd like to talk about later on in our discussion. And then the last big thing is kind of our goal of what Carlos mentioned earlier is kind of fostering this long-term learning. So there were kind of 2 parts to the final project for this class. The first is a presentation, which we just heard a little bit earlier, which was super fun. Everybody did an awesome job. And then the other part was this reference resource. So kind of the idea being that it's kind of a structured format for students to build their own set of resources so that as they go forward, they can come back and reference things really easily. So it's kind of like a structured form of note-taking. So the idea is that after a lesson or a lecture or whatever, after we pass through a subject, it's kind of like a structured way to help the students synthesize what they learned and kind of put all the big equations and variables and diagrams that they found useful when they're doing that homework or whatever, and document it into one place. So a lot of people use Google Docs, and we've seen Notion work really well in the past for this as well. But just kind of document that as a really solid way of referencing things later, make it really easy.
All right, another thing that we wanted to kind of discuss was our incorporation of ethics in these different topics. So a little background on how we set this up. We had a lot of conversations with alumni, faculty, and other people in the field to kind of get a better idea of what does ethics mean for a mechanical engineer specifically. And we did find that it varied industry to industry, which makes it a little difficult to pinpoint the exact key concepts behind ethics, especially in regards to accessibility and safety. We had 3 total lectures in the end. 1 was more of like a follow-up conversation. 2 was more us talking at the students and kind of creating this conversation about these ideas. We also had a guest appearance from someone in industry as well. But we definitely think there's a lot more room to grow, especially in future mechanical engineering courses taught at Olin as well. All right, next slide. Yep. So in terms of the setup, we started with the classic using a couple different facts about how much this impacts people. So in terms of accessibility, it's estimated that about 1 billion people, the world's population, have been estimated to experience some type of disability. And once we kind of settled the idea that this is something that's common in current society, we then kind of followed up with ideas on how the students can help improve this situation and like think more about accessibility in the design process, because it definitely deserves a seat at the table throughout the entire design process as a mechanical engineer. And we kind of focused on different lenses for specifically mechanical engineers and how they can think about thinking or including accessibility in their design process. Some of the takeaways that we found, and also what we found the students have created, was the idea that personal reflection of their definitions of accessibility is very important, just because it does vary from person to person based off of personal experiences, because this is kind of a personal topic. So recognizing that we all have maybe potentially different biases in how we want to incorporate accessibility is important to recognize, but also important to recognize that we should continue to learn and understand what it really means to be accessible. In terms of survey, we did take a survey at the end of the accessibility lecture and kind of got an idea about what students thought maybe we could do in the future in specifically Olin. And it did seem like throughout a lot of people were saying there should be a more persistent distribution of ethics and accessibility throughout the work done at Olin. And then specifically, there was a cool thing I wanted to pull out that a student suggested with incorporating some type of design constraint or requirement in future briefs or rubrics for projects throughout their Olin career. And I think this is interesting because it walks a fine line between, we don't want accessibility or ethics to be just another box to check off, but we do want to show that it is as important as any other part of the design process. So food for thought in thinking about that in the future. In terms of safety, just wanted to show a fun, quick example of one of the things that I did use from Dr. Gosbee, my father's presentations on safety, but I wanted to pull it out because I thought this was like a cool way to kind of introduce root cause analysis and kind of understanding that when you're thinking about safety and failure, you shouldn't be blaming the user, you should be blaming like the system itself. So if we want to kind of scroll through these slides here. So yeah, the situation, pulling out a car from the water, pretty simple. But then, yeah, it's not really good. Not looking good here. Yeah, that's also in the water. And yeah, so unfortunately that just happened. And that kind of just brought about the idea that maybe it could have happened that the operators were not doing something correctly, but because there was two operators that both fell in the water, it seems like this might be a systematic issue instead. So that kind of brought up the idea of using failure modes effect analysis and RCAs or root cause analyses to kind of better understand how the situation happened. Another thing that we did with these talks is we brought in a guest speaker. This was a connection we had with someone in the engineering and safety department of Universal Creative, the ones that build the theme parks over down in Orlando. And we brought him in because he had a lot of experience with thinking about engineering and safety together, because obviously that's super important when you're trying to build a roller coaster. Some of the takeaways that we found was NDAs are pretty tricky when you're bringing in a guest speaker from industry, because there's things obviously that they can't talk about. So we weren't allowed to record the session that we had, and we were only able to like take personal notes, and we obviously can't like publish those publicly. But it was very cool. I think the students enjoyed it a lot. I obviously enjoyed it a lot because it was about theme parks. But it seemed like this really created a great conversation for the students, because we had already talked to them about some of the methods of thinking about ethics, and they were able to then ask these really great questions to our guest speaker and kind of really dig deep into some of these topics. So we think this could be a very interesting tool for the future in like either mechanical engineering courses in general, or also just future Olin classes with bringing in guest speakers, maybe even alumni, to kind of give those grounded examples. And then, yeah, overall, we think ethics could be incorporated more in the future, and we're going to hopefully talk about this more in our discussion after this presentation.
Fantastic. So, well, we made a bunch of different assumptions and kind of our own mental models of how we could incorporate new ideas into the ME curriculum. We really wanted to test those assumptions and kind of figure out, is our intentions ultimately making sense to the students? So we did a couple of different surveys throughout the year. At the beginning, we were really trying to figure out what is the format of the course, what is the content that's interesting, and that was also when we were thinking about doing potentially a student-taught mech solids. And then at the beginning, we were also looking at asking students about like what content they best kind of interact with. We gave them some review content as well when they're coming into the course for folks, since there was a mix of experiences when it came to like having mech solids or concurrently taking it. So we really wanted to make sure everyone felt prepared to be in the course itself. And then in October and December, we did a couple surveys, just kind of seeing, how's the course going? Are your expectations kind of aligning with what you wanted for this course? And, is it ultimately being effective in how we're doing our teaching? So there's a couple notes, I guess, on the data from the October and December surveys. There's limitations to our sample size. We only had 6 for our first survey and then 8 for our second. And that's kind of just a function of our class size. So I would take kind of the conclusions that we can make from this with a grain of salt. Some trends in this data could just be because 2 folks took the second survey versus the first one. But we'd like to think that some of the general ideas of like students wanting to interact with this content are more broadly applicable. Recently, Carlos sent out a survey that was asking kind of like the wider student body if they wanted to take the course but couldn't for some reasons. And we found that a wide variety of students did want to take it, but it didn't align because of their current like course load or for the timings or just like maybe a redundant course that's overlapping with it. And then overall, a lot of students really did want the content that we did create, and we plan on sharing out kind of like all of our slides and all of the background content so that other people can benefit from this course. So for looking at the survey itself, one of the first questions that we asked was why folks actually enrolled in this course. So for the methods of kind of what I used for these surveys is just try to kind of find some larger themes that were in people's kind of qualitative answers and just kind of count the amount of times that it's mentioned just to see like is the the course description that Carlos was presenting to you earlier really coming through to students in actually how we're teaching things. So overall, we really found that, I'm thinking about the next slide. I think for this slide, this is for why people enrolled. It did align with kind of our expectations. We wanted to teach as super seniors and kind of pass on these learned experiences that weren't in courses. So a lot of folks wanted these experiences because they wanted, some new ME depth or the idea of having more first principles. A lot of folks had, different experiences with their mech solids, whether it be from online or from different faculty, and felt a little bit more shaky than they would have liked to. So they wanted to use this as a way to kind of review that content and better solidify it for themselves. But we also saw a lot of more practical needs as well. People saw this as a way to kind of prepare for technical interviews, make their own reference resource when it came to, like down the line, having these practical skills. And yeah, I guess in the end, just learning from our mistakes a little bit. So for when it came to what I was describing before for the course description, we found that students really did at least kind of get through to the message that this is trying to fill in these gaps, at least these perceived gaps that we were all saying, and that this is providing a new depth that isn't currently provided in some ways, like bolts or static failure theories aren't things that are explicitly taught. Sometimes they're mentioned in some ME depth courses, but aren't in the standard curriculum path. And there are kind of a lot of people aligning with the idea of making a reference resource is useful and has some personal or long-term benefit. And then again, we saw the same theme of the idea of reinforcing these existing kind of foundations and kind of learning some of these more practical ME skills versus maybe aligning more with like the theoretical. So one of the questions that we asked in October and December was kind of if students' expectations for the course was ultimately what they thought they were being advertised to. I would say, again, it seems slightly deceiving because of the difference in responses, but overall, I think we could see that there is a strong support for that. We did kind of do what we set out to do, and that students at least, for whether it be good or bad expectations, at least we fulfilled what they wanted. Since this is kind of unconvincing in some ways because of our sample size, we pulled some quotes. So similar to how we did the course, this is a reference slide. We're going to send out all these slides to everyone at the end so that you can kind of look through them yourselves and maybe read it more carefully. But just to pull through it, I think a lot of folks felt like they didn't know what to expect from us. They didn't know going into it like that we had this UT Austin course. But I think the idea when it came to kind of giving these practical skills really was fulfilling those expectations. I think you can see in some of these responses that we did have some, gaps when it came to our own experience as teachers and as instructors. We didn't have that ability to kind of go up to a whiteboard or to a blackboard and just start writing off the top of our head. And that you could tell, when we were caught in lapses in our own understanding, we kind of had to come back and refigure, like, do we understand this example problem? Like, let's make sure we're not saying the wrong thing, and then then talk to students. So yeah, it was a learning process. I think, we are still students, but hopefully there was some amount of benefit in the long term. One of the next questions that we kind of asked folks was looking at current utility of MechAnalysis as a course, and also thinking about if there's perceived future utility for the course. So strongly, we saw that people were really finding some use for the course currently, and then in the future, there's strong support to the idea, at least in our second December survey, that people really felt like there was utility for the course, whether it be for kind of the reference resource, whether it be the mindset, or maybe just kind of the approach to things when it comes to looking at engineering problems. So I guess pulling a couple more quotes from there, I think a lot of people touched on kind of like some of the nuance when it came to what we were trying to approach the topic with, the ideas of, the general steps that we're taking of breaking down a problem, whether it be from different contexts, both practical, economical, ethical, and seeing it from this multifaceted kind of viewpoint versus maybe more one-dimensional, as some practical problems tend to be. And really thinking about kind of, I think, some of the takeaways that we really wanted, which was the reference resource and kind of this mindset that college is about kind of accumulating all these lessons and all these different notes. But in the long term, I need to be able to refer to it and kind of have that knowledge. And memory sometimes isn't going to serve you as well as having these concrete ways that you can summarize all these different learnings. So one of the next questions that we asked was some of the topics that we were teaching that currently are in curriculum, do they feel like that should be included? And like, what are the topics that should be included? I will say this is slightly deceiving because there are kind of different topics that people felt like should be included. So this isn't necessarily, you could say that this is broadly all topics should be included, as students later elaborated of like which ones they think should be included. But I think the bottom line is that there are takeaways from what we are teaching, that there is a desire to have it, and they wish that they had that in the current path to supplement maybe what's currently offered. So for some examples of some of the subjects that folks did want in the course, we see like accessibility engineering mentioned a couple times. I think failure and failure theories and the idea of like joint analysis is included. I know like these are kind of topics that are touched on in like Chris's FEA course, but I think students really found a lot of value in having these static failure theories, as it really helped them evaluate, I know how to build or design something, but how do I kind of close that loop in my design and analyze it, evaluate failure, and then actually make those changes to my design that are informed from that failure. And additionally, there are some misconceptions when it came to like, when can I use von Mises? The idea that even a brittle failure theory exists, and all these other concepts that sometimes are not aware, like not readily available for some students. And I think, yeah, it's nuanced and there's a bunch of different topics, but I think a lot of people came from the approach that there are certain kind of practical mechanical engineering topics like bolts or gears that aren't maybe currently being served in like some courses like Mech does. One of the next questions that we wanted to kind of like test is the idea that we really feel strongly about this reference resource, but do students actually feel strongly with this idea? Do they think it's important? We kind of see, at least in this kind of survey results, it's kind of implying that there's a mixed bag of ideas when it comes to people's strength of aligning with this idea. And we'll see in the responses that there's different reasons of why folks might find value out of this. I think it's again kind of at least swaying towards the positive of this being useful for one reason or the other, but maybe not as strong as a response as we might feel about it. So a couple of different folks looked at it from different angles. There's the idea that just the process of making this is really useful for kind of almost like reviewing the content and kind of having this way to almost do this like synthesis and reflection for maybe what you learned in a lesson and just double check your own learning. Another kind of different group of folks were looking at it from the interview prep perspective, that this is kind of my review notes. I can use this when I need to do a technical prep. And that's kind of the function that I want to use this reference resource for. And others maybe approached it from our viewpoint when it came to like long-term, I need to use this maybe in my career and I need to have a reference to like quickly kind of like revisit the subject and kind of get back into it so that I can actually effectively apply my college degree. So I think at the end of the day, it was successful that we wanted students to make the reference resource applicable to them and not kind of force our own opinions about it. So like we had them choose their own format, their own structure, and they kind of at the beginning set out like what is the goals of their reference resource. And we were more checking in of like, are they fulfilling the goals and objectives for the reference resource rather than us prescribing a goal for them and saying you need to meet this certain standard. So it seemed like in that way it was successful, but you know, it's to be tested, I guess, because none of us know if it's going to be actually serving in our careers, because none of us are currently in our careers. And then lastly, we really wanted to test this idea of like chalking versus slide decks. You know, this felt like such a very slide heavy course compared to other folks, and to see if there were benefits or deficits that we're experiencing through this process. So there was, I guess, a general satisfaction with the idea of like using these. But I think there's some more nuance of like why and when people were satisfied with these slide decks. So in the process, I think we had touched on it before, but like there are certain derivations maybe that we did with slide decks that we just rushed through so fast that it's hard to follow. And us ourselves, we're not thinking about, you know, the process of just handwriting it really allows students to follow more of like, you know, what are you thinking as you're writing this out and what are the steps that I'm making? But you know, Nathan has already touched on that there are strengths when it comes to the reference of this and having kind of maybe different formats and media that really students better interact with or can use in a way that better just helps them visualize what is this system, you know, for things like 3D More, where it's really hard to understand, you know, like which of these circles are referencing. We really think that students did get some benefit from having these kind of reference slide that we created. You know, like one manifestation that we saw is folks would just take some of the reference slide that we'd made in our slide decks and put it directly in their notes and just kind of pull from that or put that in their reference resource, which was our goal ultimately. So that worked out, I guess. So I will leave with just some general comments about like what people felt about MechAnalysis as a whole. I think there was limitations to when it came to the course being 4 credit versus 2. There were folks that were commenting on the idea that 4 would have been nice for having more depth for practice problems. Maybe if we had like a long-term design study that folks were doing throughout the course that applied some of our learnings. You know, the deficit of being a 2 credit is that we leaned heavily on lecture and less on homework. So it was a lot of us just talking to folks and hoping that it's really sticking. But you know, some folks worded it well, where it's almost like we're doing the hard work for them and like kind of synthesizing and like making all this stuff and helping it them better digest some of this content. And then I guess overall, I couldn't tell if people were, you know, sugarcoating it just to not hurt our feelings, but they seem to be satisfied. They seem to have a good time. So we hope that ultimately that there was some benefit that they couldn't get anywhere else. But just to try to summarize all these ideas, I think some of the bottom line takeaways is that there really are some of these practical and ethical topics that students really want in the curriculum, that they seem to really engage with well when it is kind of approached from the idea of like from the start that this is a context that is important to include and that this shouldn't be, again, like an add-on, as Katie was mentioning. I think it does, you know, you could say that this is overfitting to the 8 people that we do have. But I think there are manifestations that are yet to be explored, at least in our experience, when it comes to ethics in certain courses. I think there's some ideas when it comes to student agency and kind of like student learning that could be explored for how we're approaching things, and when it comes to how they apply, you know, not only in the classroom and beyond, but thinking about, you know, using the short-term career as a way to kind of influence student agency. And yeah, hopefully those are useful. We'll send them out again for your reference. I know I really quickly went through those testimonials, but I think at the end of the day, like those quotes might be more useful than some of the graphs because of the deficits I've already mentioned. So back to Katie.
All right. You must consider the future, Marty. Had to put it back to the future reference in one of these slides. So some of the things that we think hopefully will impact future either student-led courses or just future courses at Olin in general. One of the aspects was the organization. So we really focused on documentation in Notion and Drive in organizing this course with those tools specifically. This we hope is going to allow like a smoother handover from with this course content to potentially future classes. And it was a really great basis for our organization. We used Notion. We'll show a couple screenshots in the next slide of how we set that up in Notion and how we kind of integrated that with both Drive and the recordings that we did. Speaking of recordings and documentation, I think me being in Italy really forced us to document very well, and making sure that like every single class was easy to zoom into. We had the camera going, the audio was set up well, and I think this could be like a good reference or framework for future courses that might not be as accessible now, but can be in the future, with thinking if someone is completely remote, especially as a teacher, like how do we make it better integrated for those remote people. Another thing that helped us with documentation was the fact that we were trying to future-proof this content and this class, and this kind of formatted the way that we documented the information in the slides that we put together. And as Nathan was mentioning earlier, we really tried to tell a story with these slides instead of just having it as equations or writing out problems. Like we really wanted this to be a reference for students in the future, so they could go back to a specific slide and say, oh yes, I remember how like these bullet points are now pointing towards this equation that then is this type of concept I'm trying to remember. And here's a couple screenshots of our beautiful Notion. Our Notion master Colin was wonderful in setting this up. Refer to him for like any Notion questions.
Yeah, and just to this slide, the reason we included it is because we used it as a way to kind of work with our TAs. And so we kind of created a guidelines when it came to grading and made it easy for kind of TAs to just have one page to look at, like how do I do grading? What are the links that I need to have? And like what are kind of the policies that we're using, and what should I refer to later on? So we really wanted to make it so that there was less need for us to constantly have like back and forth conversations, but these almost like how-tos were always accessible for folks to kind of have the agency to kind of work on grading on their own.
Speaking of TAs, we wanted to give a quick shout out and thank you to everyone who helped make this course possible, including our wonderful TAs and also our wonderful faculty advisors and other professors who've kind of guided us along and really enabled us to measure up to our potential. Also, the registrar and the rest of ME faculty and the ARB was very helpful in making this a reality as well. Some other acknowledgements of different sources that we've used over the semester. And some concrete conclusions and ideas. These are stuff that we kind of want to then lead into this conversation that we're going to have after this presentation. So the idea of using this course repository that we're just mentioning with Notion, but then also these student resources, creating these student resources and encouraging this self-directed learning with opening a textbook, which is wild thought at Olin. And then also encouraging the students to create these reference resources and kind of do the long-term note-taking rather than short-term. And then also we wanted to point out the use of the alumni network really helps the creating these grounded examples, and then also just giving a better perspective into what Oliners might be doing after we graduate. Okay, so enough us talking. We now all want you to talk instead. We've created these overarching 4 discussion topics that you might want to focus on or not, or we're kind of just like making this more of a free form discussion. We want to have some concrete ideas by the end of it, but we also want to kind of hear what your thoughts were on what we just presented on, what your personal thoughts are on just the overall ideas. We have a mural board for those who are virtual, and I'll be like spearheading that, but the in-person people can group up as the in-person people want. yeah, I don't know if anyone else wants to say something. Thank you all for coming also.